So example, find the Z transform of f of k equal to 1 by 4 raised to mod k for all k. Note that here it is a mod k, it means that negative and positive k. So solution, given f of k equal to 1 by 4 raised to mod k, where for all k. So f of k equal to 1 by 4 raised to mod k for all k. So same thing I can write as it is equal to, it is 1 by 4 raised to k if k is positive, and 1 by 4 raised to minus k when k is negative. Note the case, because if k itself negative, then power is minus k, because here mod k we are taking always positive. If negative, 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 it becomes positive. And by this, it is very simple by using the table of Z transform. So method 1. So by using the table, as we know the Z transform of a raised to k when k is greater than or equal to 0 and k is less than 0. Therefore, Z transform of f of k equal to Z transform of 1 by 4 raised to minus k plus Z transform of 1 by 4 raised to k. How? So when this one minus raised to minus k. So raised to minus k when k is less than 0 and raised to k when k is greater than or equal to 0. Means same thing I can write as Z transform of, so say this one, it is a 1 by 4 raised to minus 1 and raised to k, and due to this inverse it becomes 4. So it is a 4 raised to k. So I am getting here 4 raised to k plus Z transform of 1 by 4 raised to k. Note that here k is less than 0 and k is greater than 0, and by using the table, since this one, so by using this I am getting Z transform of f of k, that is equal to k is less than 0. So a raised to k, so here 4 raised to k means a equal to 4 there, and therefore I am getting z upon a minus z means 4 minus z, where mod of z is less than 4. Less than mod of a means it is 4, plus k is greater than or equal to 0. I am getting a raised to k. Z transform is z upon z minus a. So z upon z minus a is 1 by 4 there, and condition is mod of z is greater than 1 by 4. So simplify this. So I am getting Z transform of f of k equal to z upon 4 minus z plus z upon z minus 1 by 4, and here by using these two conditions, so mod of z less than 4 and mod of z is greater than 1 by 4 means what? 1 by 4 is less than mod of z. I can write here 1 by 4 is less than mod z, and since mod z is less than 4. So this is your Z transform of f of k. One may simplify here, but not necessary. So how? So Z transform of f of k, it is a z upon 4 minus z plus, here multiply numerator and denominator by 4. So I am getting 4z upon 4z minus 1, and simplification means LCM is 4 minus z into 4z minus 1, and here z into 4z minus 1 plus 4z into 4 minus z. Common out here. So I am getting z common. So inside I am getting 4z minus 1 plus z common. So 4 into 4 minus z, I am getting here 16 minus of 4z. Whole divides 4 minus z into 4z minus 1. So minus and plus 4z get cancelled, and minus 1 plus 16 is a 15, and I am getting final answer as z transform of f of k equal to, it is a 15z upon 4 minus z into 4z minus 1. Condition is same, that is 1 by 4 is less than mod of z is less than 4, which is your required answer or final answer, you can say. So example, find the z transform of f of k equal to 2 raised to k upon k factorial, where k is greater than or equal to 0. So I suggest you, when the factorial term is there, so instead of direct formula, for MCQ it is okay, direct formula a raised to k upon k factorial, k is greater than or equal to 0. You can use, but here use definition of Z transform. So what is it? So solution given f of k equal to 2 raised to k upon k factorial, where k is greater than or equal to 0. And therefore by definition of Z transform of f of k equal to summation k varies from minus infinity to infinity f of k into z raised to minus k. But here it is a k is greater than or equal to 0, and that is why z transform of 2 raised to k upon k factorial equal to summation k varies from 0 to infinity 2 raised to k upon k factorial into z raised to minus k, and that is equal to summation k varies from 0 to infinity. Note that this part, it is a 2 raised to k into z raised to minus k. I can write it is a 2 by z raised to k, because this one it is a 1 by z raised to k. So here I am getting it is a 2 by z raised to k upon k factorial, and now you substitute k equal to 0 to infinity. So I am getting here k equal to 0, so 0 factorial is 1 and raised to 0 is 1, so I am getting simply 1 plus 2 by z upon 1 factorial means 1 plus 2 by z whole square upon 2 factorial plus 2 by z raised to 3 upon 3 factorial plus and so on. It means that I am just putting k equal to 0, 1, 2 and so on. So this one. So by using standard series of e raised to x, since e raised to x equal to this, I am getting z transform of 2 raised to k upon k factorial equal to here 1 plus x means simply this one, x square means this one. So what is the x here? It is a 2 by z. So I am getting e raised to x means e raised to 2 by z. So this is your z transform, required z transform. So here is an example. Find z transform of f of k equal to 2 raised to k upon k factorial, where k is greater than or equal to 1. So by this example, you will get here why I am going to suggest you use the definition and formulas for series, because here condition is different. K is greater than or equal to 1 means k equal to 0 is not there. So therefore solution is by definition of z transform. Z transform of f of k equal to summation k varies from minus infinity to infinity f of k into z raised to minus k. And therefore here what is f of k? It is a 2 raised to k upon k factorial, and k is greater than or equal to 1, and therefore I am getting z transform of 2 raised to k upon k factorial equal to summation k varies from 1 to infinity f of k means it is a 2 raised to k upon k factorial into z raised to minus k. Same thing I can write k varies from 1 to infinity summation. It is 2 by z raised to k upon k factorial. How? Because here 2 raised to k and z raised to minus k, I can write as 2 raised to k and 1 by z raised to k means 2 by z raised to k. And now you substitute here equal to k equal to 1, 2, 3, 4 like that. And I am getting z transform of 2 raised to k upon k factorial is nothing but k equal to 1 means 2 by z upon 1 factorial plus 2 by z whole square upon 2 factorial plus 2 by z cube upon 3 factorial plus and so on. Again using same standard series, that is e raised to x, I am getting, since by this series I am getting Z transform of 2 raised to k upon k factorial equal to, so it is a x, it is x square, x cube. It means that this part is there up to infinity. So I am getting it is, if we consider 1 this side, so it is a e raised to x minus 1. So what is x here? X is nothing but 2 by z, and that is why I am getting e raised to 2 by z minus 1, which is your required answer or required Z transform. Now I am going to consider the examples by using the properties of Z transform. So you recall all the properties of Z transform by using this table, and remember this table as it is. Here f of k, this is any sequence, and we know the Z transform of that. And then if we multiply with a raised to k, e raised to minus ak, with that f of k, I can write directly the Z transform of it. If we multiply by k raised to n, or division by k, so you can remember directly the Z transform of that. Also you remember the table of Z transform, and let's consider the examples on the Z transform using properties. So example, find the Z transform of f of k equal to 2 raised to k into hyperbolic sine alpha k, where k is greater than or equal to 0. So solution, note that here if we just split into two parts, so you can consider it is a raised to k into f of k. So what is f of k? It is this one. So we should know Z transform of hyperbolic sine alpha k. So by using the standard Z transform, I can write it as, since hyperbolic sine alpha k, the Z transform is Z into hyperbolic sine alpha upon Z square minus 2Z hyperbolic cos alpha plus 1, where mod of Z is greater than maximum of mod of e raised to alpha and mod of e raised to minus alpha. So directly I can get it, Z transform of hyperbolic sine alpha k equal to Z into hyperbolic sine alpha upon Z square minus 2Z hyperbolic cos alpha plus 1. Condition is mod of Z is greater than maximum of mod of e raised to alpha and mod of e raised to minus alpha. Now I want 2 raised to k into hyperbolic sine alpha k. So by using a property of Z transform, we have this Z transform of a raised to k into f of k is a f of z by a. It means that if we have this, so directly every z replaced by z by a. So how to use it? So since if Z transform of f of k equal to f of z, then Z transform of a raised to k into f of k is nothing but f of z by. So how to use? So very easy way. Z transform of, therefore Z transform of 2 raised to k into hyperbolic alpha k we want. So you can see here, if we have f of z, means this is a f of k now, and this is f of z. So in this f of z, if we multiply with a raised to k with this f of k, I am getting every z replaced by z by a, means here 2 raised to k means every z here replaced by z by 2. The same thing I can write as Z transform of hyperbolic sine alpha k. This is our f of k, and in this case every z replaced by z by a means z by 2, and that is why I am getting it is a z into hyperbolic sine alpha upon z square minus 2z hyperbolic cos alpha plus 1, and in this z replaced by z by 2 means every z replaced by z by 2. So I am getting Z transform of 2 raised to k into hyperbolic sine alpha k equal to z by 2 into hyperbolic sine alpha upon z by 2 square, because it is z square and we are replacing z by 2. So minus 2, z means z by 2 into hyperbolic cos alpha plus 1. So simplify here. Note that here I am getting z square by 4. So denominator maximum 4, because here denominator 2 but here 4. So throughout numerator and denominator multiply by 4. So I am getting simplified answer as z transform of 2 raised to k into hyperbolic sine alpha k equal to, so multiply by 4 numerator and denominator. So I am getting, it is a 2z into hyperbolic sine alpha upon z square minus, so if we multiply by 4, this 2 to cancel but multiply by 4, that is why 4z into hyperbolic cos alpha plus 4, which is your required answer. Note that here condition is same, that is a mod of z is greater than max of or maximum of mod of e raised to alpha and e raised to minus alpha mod of. So it is your required answer or z transform. Find z transform of f of k equal to e raised to minus 3k cos of alpha k, where k is greater than or equal to 0. So if we see the properties there, that is a multiply by a raised to k into f of k, we can use here. So what is the a raised to k? If we see there, it is a e raised to minus 3 raised to k. It means that a equal to e raised to minus 3. So solution. First of all, you just find the z transform of cos of 4k by using table or standard z transform. Solution, since z transform of cos of alpha k is nothing but this one. So it is a z transform of this. So solution, we know z transform of cos of alpha k equal to z into z minus cos alpha upon z square minus 2z cos alpha plus 1, where mod of z is greater than 1 and also k is greater than or equal to 0. And therefore, by using this, I can write z transform of cos of 4k equal to z into z minus cos alpha, alpha is now 4, whole divides z square minus 2z cos alpha means cos 4 plus 1, where mod of z is greater than 1. Now I want to use the properties. So by property of z transform of a raised to k into f of k is nothing but, you first find z transform of f of k, and in this case every z you replace by z by. The same thing if we consider z transform of f of k is f of z, then I can write it as f of z by, and therefore z transform of e raised to minus 3k into cos 4k equal to z transform of cos 4k, and everywhere z replaced by z by a. So what is the a here? If we check here a, it is the a raised to k. You compare with e raised to minus 3k, it means that it is e raised to minus 3 raised to k. So what is the a? It is the e raised to minus 3. The same thing you can consider that it as e raised to 3 into z. So every z replaced by e raised to 3 into z. So we have z transform of 4k already. So it is a z into z minus cos 4 upon z square minus 2z cos 4 plus 1, and here z replaced by e raised to 3 into z. So I am getting z transform of e raised to minus 3k into cos 4k equal to e raised to 3 into z means what? E raised to 3 into z minus cos 4 whole divides z square means e raised to 3 into z whole square minus 2 z means what? E raised to 3 into z into cos 4 plus 1. Same thing I can write after simplification. Z transform of e raised to minus 3k into cos 4k, that is equal to e raised to 3 into z into e raised to 3 into z minus cos 4 whole divides. Simplify it, I am getting e raised to 6 into z square minus e raised to 3 into 2z into cos 4 plus 1, which is your required z transform.